Good day, everyone. So today is our third video on machine learning with Python. So today I will still talk about multiple linear regression, but I'm going to use a different library to do multiple linear regression. In my last video, I used scikit-learn, but this time I'm going to use statsmodels. Let me share my screen. Like we normally do, we start from Anaconda, then you launch your Jupyter notebook. I have my Jupyter notebook. You locate your file, where your file is, or you start a new file. Either you locate where your file is, or you start a new one. Now I have my own file that we used in the last video, and we're going to continue. We're going to continue from there. So this time we're going to use a new library. The last time we used scikit-learn, and from scikit-learn.linear model, we imported linear regression. This time we are going to use a different library, the statsmodels. So if you don't have this library, you can install it. How do you install? So we are using statsmodels. You can do pip install. So I already have it in my system. So after installing it, it will ask you to restart your kernel to update the package you just installed. So to restart your kernel, you go to kernel, then you can restart. Either you restart and clear all output or just restart. So let me restart and clear all previous output. It clears all the outputs. Okay, so I don't need this again. I can delete this. So look at all the packages we need. So after installing statsmodels, we need this, and we need this API from statsmodels. So we're going to call all the, instead of me writing this every time, I'm going to call it SM. You can choose to call it anything you want. Well, I'm going to call it SM. Then from scikit-learn metric, I'm going to import mean square error to calculate the performance of the model, like I explained in the last video. So I'm going to, instead of me writing NUMPY numpy every time, I'm going to write NP. So I'm importing this as NP. What's the difference between this and from? So in this case, I'm not importing this. I'm not importing scikit-learn metrics. Rather, I'm importing mean square error. But the mean square error is located in scikit-learn metrics. If I import scikit-learn metrics and I want to use mean square error from it, then I have to do scikit-learn metrics dot mean square error. But I don't want to, that's too long. So I can import just mean square error instead of importing all this. Importing mean square error. But mean square error is found where in scikit-learn.metrics. So what I'm telling Python is from scikit-learn.metrics, import mean squared error. I'm going to import this. I'm also going to import this function that we are going to use to fetch our data set. The data set we are using is in the scikit-learn package, scikit-learn.dataset. So we have a lot of data sets, inbuilt data sets that we can use to learn, to practice, and they are all in dataset. And this dataset is in scikit-learn package. So now I'm not importing. What I'm doing, I'm importing this function, and this function is found in a scikit-learn.dataset. The same with this, we are going to split our data like we did in the last video into train and test sets. And the function we are going to use is the train test split, and the function is in scikit-learn model selection. So this will be using these packages. Then I'm going to set seed so that I can replicate my result. I explained this in detail in the last video. Now, in this place, I fetched the data set, the inbuilt data set in scikit-learn. So this ID number is telling Python the exact data set I need. So we have different ID numbers. So if I change this ID number, I will get a different data set. We are using the Boston housing data set. I explained it in the last video. Do well to watch the last video. Okay. Then the next is to split your data into X and Y. Let me show you something. So now I fetch this data set and I call it Boston. That's what I did here. Now the next step, I want to split to X and Y. If I do Boston dot target only, it shows me Boston dot data. US. Okay, I didn't run. I'm here to run this. That's why I'm here to run this. So let me copy all this and run. Okay. So now this is the data. So Boston.data, this is the X variable, X variable. Then if you want to see your Y variable, you call it target. This is the Y variable. So Y variable is target, X variable is data. All are in Boston data sets. Now, if I want the data set without the column names, I can then add values. So values gives me the data set without the column names. So that's what we have. That's what we have here. This other part is if you want to change the data type, if you want to change it to float, if you want to change it. So let's try that. So this is how the data is. The data type now is objects. So if I want to change the data type, I'll put dot as type float. So this is it. It's just like changing data type. Before it was this object. If I want to change the data type, so that's what it is. Now there are some function that you want to carry out. It may not work with this data type. It may need you to change it to a NumPy array to this other data type before it can work. So that's why you have to learn how to change data too, because sometimes you have to move from integers to float, integers takes whole numbers to float, and move from one data type. You need to also learn how to move to data frame and the rest. So you just learn how to change your data type. So back to this. So what I did here is, so this is for X. I've explained this, why this is for Y. So what this is doing is just changing the data type. It's not compulsory. If I take it out from this, the analysis will still go through. I will explain why I added it in the next code. So the analysis will still go through. In the last video, I explained this, our train and test set to avoid overfitting. And we are using 80% to train the model, 20% to test it. So now this is the new part we are learning today. We are using start model instead of scikit-learn. And start model, I called it SM. So whenever you see me write SM, you know I'm talking about start model. Then you have to be careful. Python sees SM now as start model. So don't name any variable as SM again. Let the SM be unique and kept for start model package. So now the next step is to fit your model. So after you split your data, you have to fit your model. So what do you do? So if you import, the next step is to fit your model. You use your Y train as your response variable, then X train as the predictor variable. This is start model, and you are telling the Python that you are fitting an OLS, ordinary least square regression model, your Y variable and your X variable. The next step is to use, you can call this any name, any name. Yeah, I called it model. You can give it any name. The next step is to use this function fit. When you put dot fit, what Python does is Python will try to estimate all the parameters of the model. So what are the values of this slope? What is the value of the intercept? So that's how it works. Python tries to fit all the parameters of the model. One thing about this is this step, I can decide to delete this step and put the dot fit here. It is still the same thing. Either you break it into different steps. If you want to break it into different steps, the first step is just tell Python your Y variable that you are going to use to estimate the parameter and the X variable. Then the next step, you can then put your dot fit. If you want to do everything at the same time, you can then put dot fit after telling Python your Y and your X. So both do the same thing. So if I do this, then what I will continue using is the name model, because model contains both my X and Y and also dot fit. So what I will continue using is model. So what I mean is this place will become model. But if you are breaking it into different steps, like I did before, what the name you are going to continue using now is the new name. Results is not a fixed name. You can change or use any name you want. I decided to use results. You can use any name you want. That is it. Let me cut all this and move to the next line. So this is it. So after fitting the model, it estimates all the parameters of the model. So we are going to use results from henceforth. If you want to see the parameters of your model, you can do results dot params. So I need to run this. Oh no. Let's see the error message. Y train, X train. Wait, let me see. Type float. As type float. Okay. So now, so that means the function only works with floats if the data type is float. So you have to convert from data frame to NumPy array. Now, these are the parameters of the model. The parameters of the model. I will explain the next code. I'm going to explain how to add an intercept. In this model, there is no intercept. It has only slope. I didn't include intercept. If you are using scikit-learn, like the linear regression, you don't need to tell Python, I want intercept. I want to include intercept in my model. Python automatically gives you an intercept. If you want to, you have to learn about multiple linear regression model to know what I mean by intercept. So if you are using a scikit-learn package, it gives you intercept and slope. But if you are using the stat model, you have to inform Python if you want an intercept. So the first code I'm running, it is giving me coefficient without an intercept. If I want an intercept, then I have to tell Python I want an intercept. I will explain that after this. So what I'm getting here are slopes, different values for my slope. You have to learn how to interpret this. Now, why am I using stat model? Because scikit-learn also gave me this. The reason why I'm using this stat model is that stat model also gives us other things. It gives us p-values of the slopes. Tells us the coefficient that is not significant and the coefficient that is significant. If you want to know all the possible, like all the results available in this function, what you do is, if you do di arrow result, like you can ask me, how did I know it is PAROAMX? If you do this result I'm using is not a function, it's because of this name. So if I change this name, I have to change the result here. So the function here is di arrow. So it gives me, look at all the, if I want to see any result, look at all the things I can use. So if I use this, it gives me a different value. If I use it gives me a different value. So these are the different possible value I can get. So if you check here, you see, so this means if you want to see the coefficients, the parameters, if you want to see p-values, this is what you use. So dot p-values. So now let's use p-value. If I put result dot p-values, it gives me the p-values. So these are the p-values. How did I know this is what I'm supposed to use? I got it from here. All the available options. If you want to see AIC, BIC, and the rest, if it is available, like if I want to see the F value, so let's try this F value or t-test. So let's try t-test and see what it will give us. So these are all the available options. So it just gives us this no value. Let's see F-test. Fitted values. Okay, fitted values. Okay, so this is the using your model now to predict the Y value. You can now compare the Y predicted for your train sets with the true value and see if your model is performing well. Now, I've shown you how to see all the available options in the model you just fitted. You use the arrow function to see all the available options. So for now, we are interested in p values and the parameter. So p values, we use it to know if the coefficient is significant or not. When the p-value is less than a selected level of significance, it means the coefficient is significant. So what this means is if I'm using 0.05 as my level of significance, it means this is significant. The first coefficient is significant, second is significant. The third is not significant because this value is greater than 0.05. This is significant, so that's what it means. Then you also have to learn how to interpret coefficients. If you want to interpret coefficients, so let's go back to params. That gives us the parameters. If you want to learn how to interpret this, so what this means is holding all the other variables constants, holding all the other variable constants. The change, okay, I will interpret this later because I need to know what the first coefficient is. I will interpret it later. Let's leave that. So I've explained how to see all the available options. We are done with this. Now, if you want to see, okay, if I want to see the column names, I will go back to my data set. So remember, data set is this Boston, and we'll call this X. So if I go to Boston dot data, it gives me the S value. If I want only the coefficients, I will do dot columns. So it gives me the coefficient. Okay, now let me interpret. So this is what I was waiting for. So CIRM, it means the crime rate. If I want to interpret this, what this means is holding all these other variables constant. For every 1 unit increase in crime rate, the price of houses decreases by 0.1. So that's what this means. For every, then if I want to interpret this, for every 1 unit increase in Zn, holding the other variables constant, the price of a building increases by 0.03. When it is negative, it means decrease. When it is positive, it means increase. So this is how to interpret your coefficients. If you want to see remember how I got this? If you want to see all the columns in your data set, you use the function dot columns. So this is my data set. This is my data set. If I just want only the column, I do this. It gives me the column. So that's what I did here. And I explained list in my first video. So I want to call all these variable names because I will use it. I want to rearrange my results. You have to learn how to present your results well. I've explained result of params, that's if you want to see your coefficients. I've explained result of p-values if you want to see all the p-values. Now I want to arrange all these results to be positioned well. You can also decide to create a table, but that's not what I'm doing now. You can create a table. I think that is even easier. You create a table, a data frame, and place all these results that you have now in this table. But if you don't want to do that, let's say you want to do what I did here, you can decide to use for loop. So for loop, I can use anything here. So I can do for loop. I can use either I, J, K. It depends on what you want to use. Or you can use something that you can easily remember. So the variable, I can use name for the first one. Then the second one, COE, meaning coefficient. For the third one, I can use p-value, p-val. You can use anything you want. Because I'm doing more than one, I'm considering more than one variable in my for loop, I have to use the function zip. If you are using just one, you don't need the function zip. I explained for loop in my first video. So I'm using 3 variables at a time. In my for loop, I have to use the function zip. So the first item I'm going to write will belong to name. The second item I'm going to write belong to COE. And the third item I'm going to write belong to p-val. So name is coming from variable names. COE is coming from coefficients. Then p-val is coming from p-values. Then you put your colon, enter. So it means name is going to pick the first name in this. COE is going to pick the first coefficient. P-val is going to pick the first p-value. Then it will group the 3 of them. So how do you want your result? First, let me round the coefficient and make sure that the decimal place or decimal places I want is 3. So let me make sure that the decimal places is 3. I can do COE round. You can write any name you want. So what I'll do is round COE in 3 decimal places. What about the p-value? Do you want to round it? I can do, no, wait, underscore, please, underscore. I can do p-val round p-val 3. So 3 there means 3 decimal places. So I'm okay with that. If you want to make a comment, you can write your comment rounding, or just put 3 decimal places. So it's good to write comment to make your code easy for anyone that looks at it to understand. Now I want to print. How do you want your result? I want to print my result. I can do print. I can just do print name. print COE round, print pval round. I can just do that. But the result may not be too good. Do you want it like this, or do you want to write? You want to make some statement you want to write? If you want to write, then you have to change how you print your results. I can do something like this. Print. I explained this in my first video. I can do this. Print. So I can do coefficient. But let me just use what I have here. Okay, I can do this. Will be for name. Name. Then the next will be the coefficient value, COE, round, coefficient, then the value. Then if I want to make some statement before writing the p-value, I can do p-value equal to, so I do this. So what will be here is name. What will be here is round. Then what will be here is p-value. The p-value I estimated, p-value round. Okay, so this is how it is. Depending on that. So I don't want this again. I can delete this. So if you want your results, if you want to make more comments here, you can make the p-value, for this coefficient is, so that's it. So what this is doing, this for loop is iterating over these three variables. So that's what I did here. But this is not that important. What is important now is we have the coefficient, we have the variable, we have the coefficient, and we have the p-value. So it tells us if the variable is significant or not. So it means this is significant because it's less than 0.5. This is not significant. This is significant. This is not significant. This is significant. So whenever the p-value is less than 0.5, it is significant. So that's all for that. Then if you want to calculate ROMSE, when I did DIRO, example, if you do, I did DIRO, result to see all the available options, all the options I have. If you check, you also see predict. So you have arrow squared. If you want to know the arrow squared value, you also see predict. So that means predict is part of the available options. We have been using params and p-value. We also have arrow squared. If you want to know the arrow squared value, arrow squared adjusted. So these are all the available options you have. Now let's make use of predict. We use predict to predict both the train and the test sets. And that's what I did here. So if you are predicting the train set, you use result.predict. Result is not unique because of the name I used for my model. That is why result is not unique. It is because of this. So any name you use here is what you will use. It's what you will use here. So you can decide to change the name. But predict is unique. Predict is a function. Predict is a function. Result is your model's name, but predict is a function. Then this is your X variable. Now, what do you want to predict? Now, let me predict the train set first. Then I predict the test set. You can call this any name you want, any name. This is not unique, any name. So this is what I decided to use. You can give it your own name. So after predicting, you compare your predicted value with your true value, like I explained in the last video. And this gives you the root mean square error. The good thing about this stat model package is that it gives you a lot of options, unlike the scikit-learn package for linear regression model. So this gives you a lot of available options. It gives you p-values and many other things. Because before you interpret your results, you have to know if that variable is significant or not. Okay, so that's all for this. The other thing I want to explain is if you want an intercept, then you have to add an intercept like I did here. Remember, SM mean your stat models, then dot, these are available options in this package. So you can add constants. That means adding an intercept. So you have to add the intercept before you split your data into train and test sets. Then every other steps are the same. Every other thing are the same. But this time, your result is going to give you intercept, and it's also going to give you all the slopes. Because if I don't want the intercept, this is what I will do. Under model.parameters, I'm going to tell Python. I know that, remember, Python starts counting from 0. 0 means the intercept, but 1 is where the slope value starts from. So I'm going to tell Python, if I want only the slope, start from 1, don't start from 0, because 0 is the intercept. Now, if I want to see the intercept value, what will I do? If I want to see the intercept value, all I have to do is call this 0, and it gives me the intercept. So this is the intercept value. If you want to see, let me run this. So this is the intercept value. If you want to see, let me see. No, sorry, this is model. This one I use model in this place, not results. So I have to change this to model. Okay, so this is the intercept value. And let me show you that this is exactly what we got when we use the scikit-learn package. Let's just do this very fast. So this is the scikit-learn package. In my last video, I seen exactly the same value, exactly the same value. Exactly the same value. So if you want to add an intercept, then you make use of this function, sm add constant. But if you don't need it, you just want to get your slope and fit your regression model, results will be pretty similar, pretty the same. The Python will know how to use the model you are giving to it to estimate the parameters. So the result will be pretty the same. That's all. So my next video, I'm going to explain either artificial neural network or random forest. So we're going to stop here for today. Thank you. Do well to like this video, share, subscribe, make your comments, and if you have any question, let me know. Okay, thank you.